Now we check the pinhole. It's time to check the fit on the plate, sub plate rather, or fixture plate to that. So I'll put this down, grab our pins, and oh, there's one, and there's two. Look at that, it's good. I place these holes in a very specific location and I tighten them in a very specific order because even though this plate is, I think it's 2 thou parallelism over like quite a distance, probably longer than this plate. No matter if this plate's bowed like this or this, if I tighten it the way I'm going to tighten it, it will suck everything down. So two bottom ones, I'm going to suck down that part, and then these ones, the side, over here, and this one. And it doesn't matter, like, just make sure you do all 4 of these at the same time. And this. So if you imagine if this thing's bowed like this, these are pulling it down flat here. And then even if there's a cup this way, these are going to pull it down in the center. And then I can go around to the corners, tighten those up. And I do like to do these in kind of crisscross pattern on the corners. So now everything is pretty tight down to that subplate. And we can go ahead and machine this and put a nice little chamfer on it so it doesn't hurt anyone's fingers. Got a hole through here, clamps onto a circular part. Just assembling these up, getting ready to finish up the holes in those. Alright, over here at the fixture for drilling those holes, just want to explain how I'm doing it accurately. I've got this fixture here, this face and this face are perpendicular milled at the same time. And then this is trued up, this bottom face here that it attaches to. And then my part 0 is this face, and these butt right up against here. And I'm perpendicular within about a 1/2 thou. Okay, so one really important point when drilling and reaming really deep holes is I've done a pilot hole and then I've helically bored the starting hole for the drill ream. Okay, so all these precautions we're taking here with perpendicularity and pilot hole boring and everything gets you some pretty good results. So basically the fixture, very important that this bore be the axis of that be parallel to this face. Now, what I've done here is I've zeroed on the high spot on this. This is a gauge pin in here, and we're going to inspect how parallel they are. So this should be zeroed out already on the high spot. Alright, plus 2/10. So if I go and move this pin over, fortunately I don't have a gauge pin long enough, so now it's on the other side. So find the high spot on that guy, and that is plus 5/10. So 3/10, because we were at 2 and now we're at 5, so 3/10 parallels in between the axis of this bore I've made, and that's with traditional tooling, high-speed steel, generic drills and stuff. It's just taking the precaution goes a really long way. All right, we got the fixtures together, and we're going in to do a little program to finish up the machining on it. So down here, on these parts here, I've purposefully left 10 thou on each of these faces, and that's so that I can mill these with the fixture pinned in place relative to the machine, because we do have a critical feature on the part that we're making. It's a drop from this face into one that I'm about to mill in. So we're gonna get that done.